So the last step after we've dealt with arithmetic sequences, finding missing terms, finding number of terms, and a couple of word problems, now we're talking about finding the sum of the series. I will give you the heads up. You guys freaked out on me during arithmetic series saying how difficult it was, even though it really wasn't that difficult. But this is easier, at least in my opinion. The one thing that might be a little challenging will be entering it into the calculator, which I'm going to show you how to do.
So first we need to learn what the geometric series is. And that says it's an indicated sum of terms of a geometric sequence. So then we have S sub n equals T sub 1, parentheses 1 minus r to the n, over 1 minus r, parentheses.
So this is the formula we're going to use today to find our sum of our series.
So then it says n equals the number of terms in the sequence. T sub 1 we should remember, which is our first term, and r equals our common ratio.
Now one thing you will notice, there is no T sub n in here. So that's a good thing because we don't have to find T sub n.
And then we have summation notation. So we come back to our wonderful formula we've seen before. Number on the top is our stop. Then we have our explicit formula, and then we have k equals our number, which is our starting point.
Remember, this is always going to start with 1. But here's the nice thing. If you think about it, our explicit formulas for arithmetic were basically in the form of y equals mx plus b. That doesn't give us really, I mean, it sort of gives us a starting point, but it gives us our y-intercept, which would be like term 0. It doesn't give us term 1. But if you recall, explicit formula for geometric gives us term 1, it gives us our r. So there's not much to do for it, and you'll see that as we get there. So let's try our first problem. So step 1 is going to be to identify the pieces. Step 2 is going to put them into that series formula, and then add up the terms to check. And I know some of you are probably going right now, well, there's only 6 terms there. Why can't I just add them up? That's an excellent question. But what happens if I don't give you the first 6 terms? I give you the first 56 terms. It's going to be a lot faster to simply put it into the formula than to try and just add them up. So we're going to start here with using the formula. We know that our formula is S sub n equals term 1 times 1 minus r to the n over 1 minus r. And so that means I need to know n, I need to know r, and I need to know term 1. Well, n, it says here, 6 terms, so n is 6. Term 1 is 2. And to get r, I'm going to take the second term divided by the first term, which is going to give us an r of 2. So that means that our equation is going to say s sub 6 is equal to term 1, which is 2, times 1 minus 2 to the 6th over 1 minus 2. Well, 2 to the 6th is 64, so we got 1 minus 64 over 1 minus 2. 1 minus 64 is negative 63 over 1 minus 2, which is negative 1. Negative 63 divided by negative 1 is positive 63. So then we multiply 2 times 63 and we get 126. Now if we were to go ahead and add up each of these terms, we would still get 126. So it's pretty slick. Looking at a second example. Here we know we need to know n, we need to know term 1, and we need to know r. N is 1, 2, 3, 4. Term 1 is 3. And r, we're going to take second term divided by first term, which gives us 3. So that means now we're going to find the sum of the first 4 terms, which is term 1, which is 3, times 1 minus our ratio of 3 to the 4th power over 1 minus 3. 3 to the 4th is 81. So now we got 1 minus 81 over 1 minus 3. Well, 1 minus 81 is negative 80. 1 minus 3 is negative 2. Negative 80 divided by negative 2 is 40. 3 times 40 is 120. And if I go ahead and add up 3 plus 9, which is 12, plus 27 is 39, plus 81 gives us 120. So pretty slick.
Now those of you thinking, why are we dividing to find R? When I can look at the pattern and go, oh, 3 times 3 is 9, 9 times 3 is 27. Because what happens is that it's always not going to be a nice little wonderful neat number. It might have a decimal. So we'd rather have you understanding that we need to take the second term divided by the first term to find out what our R would be.
Yeah. If you can look at it and identify what R is just by looking at the sequence, have at it. We're doing it by hand so you can see where these numbers are coming from. Now, we've got 3 plus 4.5 plus 6.75 plus 10.125. Now, here's the thing. I have here, we don't know the last term. We would need to use the explicit formula to find it. However, we don't need to know the last term for this formula. So what we're going to do is just use our information we have. So we have term 1, which is 3. We have our number of terms, which is here and here, which is 10. And we have R, which is going to be 4.5 divided by 3, so term 2 divided by term 1, so that's going to be 1.5. So now, we find the sum of the first 10 terms, which is equal to term 1, times 1 minus R to the n power over 1 minus R. Well, looks a little messy to me because if you take 1.5 to the 10th power, it gets to be a really ugly number. We don't want to deal with chancing, having to round or anything like that. So what we're going to do is we're going to bring up the calculator. And I'm going to show you how you want to enter this. So if you have a calculator that does order of operations for you, you can put this in one fell swoop. If that's the case that you have one of those calculators, I want you right now writing down the keystrokes that I tell you to do, so that way, or at least learning how to write these down with all the pieces so you don't miss anything, because if you put parentheses in the wrong place, it will give you a wrong answer. So we know that our formula is 3 times, so I'm going to do parentheses. But now I have to make sure that I have my numerator and denominator separate, so I have to hit parentheses again, because the first one is for the whole group, the second one is for the numerator. So I do 1 minus 1.5 to the 10th power. Now notice my cursor is still up in the exponent, so I hit my gray right arrow to get out of it. Then I close off the numerator, say I'm going to divide that by the denominator and open up another set of parentheses. Then 1 minus 1.5, close off the denominator, and then close off that whole group. Notice those parentheses are a little bit bigger, so that it tells you need to have the same number of left parentheses as right. So we notice we got 3 and 3, we're good to go. We hit enter. And our answer is 339.9902344. And the question always comes up, should we round? No. Because while this will come out, we're pretty darn close to 340. We're not quite at 140 there because of, you could see how the decimals were getting more decimal places, more decimal places, more decimal places. So we write exactly what we have. So that means that S of 10 equals 339.9902344. No, I did not have that memorized. I have it written down in front of me. So then we look at example D. Example D. Right now you see that we've got some nice pretty whole numbers and you're breathing easy. Don't breathe easy quite yet. We have term 1, which is 12. We have n, which is 10. You can see that right here again. And then we have R. R is going to be 18 term 2 divided by term 1, which is 12. 18 divided by 12 is 1.5 again. So once again, we know it's not going to be super pretty. So we put it into our formula. Sum of the first 10 is equal to term 1 times, and then you can do this to help you with remembering with parentheses, 1 minus 1.5 to the 10th power, 1 minus 1.5. And then we go to our calculator to put that in. So we have 12, parentheses, parentheses, 1 minus 1.5 to the 10th power, arrow out of the exponent, parentheses, divide, open another set of parentheses, 1 minus 1.5, parentheses, parentheses. And you get another, not quite so ugly, but still not super pretty number. So we'll go ahead and write that one down. And we get that the sum of the first 10 terms is going to be 1,359.96093. And some of you are probably going, are all of the problems going to be this ugly? No. These ones just happen to be because the common ratio is 1.5. If the common ratio is a whole number, it's going to be a lot, or they're constantly getting bigger. Usually it's not quite as messy. So now, we've got one that is a summation. And here's what I was talking about earlier. A lot of you guys want to go, oh my god, I can't do summation. But we need to find the number of terms in the series, starting and stopping. So we need term 1, we need N, and we need R. Here's where it's nice. We know this is our stopping point, that automatically makes it R. Because when we say stop, we're stopping at the 5th term. We're going from 1st to 5th. Term 1, well, this is our explicit formula. Remember, this is term 1 times R to the N minus 1. So term 1 is 4. And R is 2. Now, some of you might be going, well, how do I know that the first term? So if we want to know that this is guaranteed to be the first term, let's put this up in here. So you get 4 times 2 to the 1 minus 1 power. Well, 1 minus 1 is 0, so now you got 4 times 2 to the 0. 2 to the 0, anything to the 0 power is 1, so now you got 4 times 1, which is 4. So, we could then put in term 2 to guarantee that R, and we would get 2 minus 1, which is 1. 2 to the first is 2. 4 times 2 is 8. 4 times 2 is 8. Therefore, our ratio is 2. So now that we've got that, we use the series formula. We go back to that. So we want the sum of the first n terms, that is 5, is equal to term 1, which is 4, times 1 minus our ratio of 2 to the n power over 1 minus 2. We could calculate this one by hand if we wanted to. I'm going to put it in the calculator because I got it available for me. So now we put in our term 1, which is 4, parentheses, parentheses, 1 minus 2 to the 5th power, arrow out of the power, parentheses, divide, open up another set of parentheses, 1 minus 2, parentheses, parentheses. Hit enter, and we get 124. So S sub 5 equals 124. Now if you want to, you could check your answers by adding up the terms. If you want to go in and find those first 5 terms, which in this case would be 4, 8, 16, 32, 64, and add those up, you'll get 124. So now what I want you to do is you do these 2 problems. I will tell you right now, your common ratio in F is a whole number. Therefore, you will have some pretty numbers for your answer. Same thing with G. And as always, bring your questions with you to class.